I'm going to be demoing my 2048 project. This was a project for the tile game 2048 where my program pretty much screenshots it, automates the web browser with Selenium, and inputs the best move with an algorithm. So here is the screenshot that it takes every time. We don't have to worry about that till later. In my main file, we need to open the page and capture the screen. This is actually hard-coded, so that's a small issue that I'll work on in the future, but right now we can just adjust that or move the screen to where these pixels are, and we can see it here, so as long as this matches up, it's okay. We have a basically infinite while loop. It creates a new board to store the state of the board. We'll go over that in board.py, and every time it pretty much just uses Selenium, it checks if the game is over too. And I have two different functions here. One of them is if we haven't made that many moves, so we'll do less calculations because we're probably not going to lose at that point. Later on, we'll do a bit more calculations to get a higher score. This is just checking the time, so we print that out. And over here, we're just checking if the game is over. That way, we can keep playing this, and I can keep my program running, and it'll play the game multiple times, and it should save it into here. So this is the last time it ran. It didn't do too well. Then in our board.py, the first few functions are to get the tile values. So what I did was, as you can see in the screenshot, every value has a different color. So I used that to parse up the board into a matrix. These are the tile values for math, and these are getting the colors. And then we need all the functionality of the actual game in here, so we need to manipulate the matrix so that it can play the game inside our program. I'll explain that because we need that in our algorithm. And we have our move up, move down, move left, move right. I was a bit lazy, so instead of having separate things, I just rotated the board, moved it back up, and then rotated it back. And then we just have a move. So based on our key press, we have where we're moving it, or based on up, down, left, right, we move it that direction. Board changes, we want to check if the board actually changes when we go down. That way we don't just keep trying to go down and the board just is stuck in the same state forever. That's not really that important. Get score is to get, I think we use this in get average score. I'll explain this in our algorithm too. And get best move and simple get best move. These are the same, I just made this one after. This one uses multiprocessing because I realized Python was really slow and these moves would all take 10 seconds each, so it would run for a really long time. What we do here is we have each of the moves, we loop through each move, and then we play the game out this amount of times for each of those moves. So let's say we press W, first it will play that move, and then we would play this board 1,000 times or something like that. Same thing for A, S, D, which is all just up, down, left, right. After this, we want to calculate the average score in each of those 1,000 games, and then the one with the best average score, we would actually play that. So that's how the program works. I think that's pretty much it. So yeah, so every time it saves it into this, so you can see this updating, and I'll show that in a second. And then Windows and Mac, I think, have different file paths for Selenium, and it might be using a different Python package too, so that's why I have two separate folders for this. If you want to see an action, I recorded this earlier, but I didn't really like it, so I'm re-recording it, and I don't want to play it again. This is pretty much what happens. So you can see on the right side, it is playing it out, sending the best moves, and then on the left side here in my program, you can see everything printing out. You can see how long it takes. It also waits a quarter of a second because you can see that the animation moves over, so that's why it takes a bit longer on this screen. You don't want to take a screenshot while it's in the middle of the animation. Yeah, and if we skip here, it starts getting slower. Each move takes like 3 to 4 seconds. You can see that it actually gets to 2048. If it gets to 2048, my program basically clicks keep playing, and then it will continue sending good moves. Usually this gets to at least 2048. It has gotten to 4096 a few times, and then other times we don't get so lucky and we don't make it to 2048, but it hasn't ever not reached 1024. Another cool thing is that we can actually send moves to the actual board. So we can just like spam our up, down, left, right keys and it would move it, and then basically the program fixes it for you too. If we just skip to the end, I'll let this play for a few minutes, and yeah. So I pretty much just let this run when I went to go eat or something like that. And then at the end, it will give you a bunch of game over file images, and you can look at basically the scores you got. And it'll play multiple games. So yeah.